define and graph logarithmic functions. If a and x are positive numbers, where a is not equal to 1, then g of x is equal to log of x with the base a, defined as logarithmic function with the base a. Graph the logarithmic function when a is greater than 1. So let's take a look at this graph. Graph f of x equal to log of x with the base here is 4. You can write this as exponential form. You recall, if I have log of x with the base b is equal to y, you can write this as b to the power of y is equal to x. So in this case, I have 4. If I say f of x equal to y, in this case, if I call this y is equal to log of x with the base 4. So here I have 4 to the power of y is equal to x. 4 to the power of y is equal to x. So this is what I am graphing here. I'm going to make a list of order pair here. If I change the value of y, I can find the corresponding value for x. If y is equal to 0, anything to the power of 0 is equal to 1. So I'm going to start with right here. If y is equal to 0, x would be equal to 4 to the power of 0, which is equal to 1. So here would be 4 to the power of 0. Anything to the power of 0 is equal to 1. So my graph kind of passes through this point here. X equal to 1, y is equal to 0. So this would be a point right there. As I increase the value of y, if I let y be equal to 1, the value of x increases. The value of x increases here. Because if it's y is equal to 1, x would be equal to 4 to the power of 1, which is 4. This would be 4 to the power of 1. If y is equal to 2, x would be equal to 4 to the power of 2, which is 16. As you see, as I increase the value of y, the value of x increases. This would be the point. But as I decrease the value of y, if I let y to be equal to -1, so that would be 4 to the power of -1, which is equal to 1 over 4. We call a to the power of -n is equal to 1 over a to the power of +n. Or if I have 4 to the power of -1 is equal to 1/4. And as you see, as I decrease this, that would be, if y is equal to -2, x would be equal to 4 to the power of -2, which is equal to 1 over 4 squared, which is 1 over 6. As you see, this curve gets closer and closer to 0. Can you imagine if this were 100, or this was -100? If y was -100, this would be, x would be equal to 4 to the power of -100, which is 1 over 4 to the power of 100. That gets really, really close to 0. That gets closer and closer to this line here, but it never touches this line. So you can collect these order pairs and retrieve the shape of the graph this way. Graph a logarithmic function, then a is between 0 and 1. So let's say we want to graph f of x equal to log of x with the base is 1/10. So I can write this as y is equal to log of x, but the base here is 1/10. First thing I do is I write this as its exponential form. Once again, y is equal to log of x with the base b. I can convert this to the exponential by writing that b, the base, to the power of y must be equal to x. So in this case, I have my base is 1/10. 1/10 to the power of y is equal to x. So this is how you convert them. Make a list of order paired. Let's y be equal to 0. Anything to the power of 0 is equal to 1. If y is equal to 0, here my x would be equal to 1/10 to the power of 0, which is equal to 1. Anything to the power of 0 is equal to 1. If x is equal to -1, so first of all, my graph going to pass us through this point here. If y is equal to -1, x would be equal to 1/10 to the power of -1. If I want to make that exponent positive, if I have a over b to the power of -n, that's the same as b over a to the power of +n. So here I would get 10/1 to the power of 1, which is the same as 10. So as I decrease the value of y, the value of x increases. Let's y be equal to 1. If y is equal to 1, x is equal to 1/10 to the power of 1, which is 1/10. If y is equal to 2, x is equal to 1/10 to the power of 2, which is 1/10 to the power of 2, or 1/100. You see, as I increase the value of y, the value of x decreases. Get closer and closer to 0. Get closer and closer to this line, y axis here. So that would be a shape of this graph. So let's take a look at the characteristic of graph g of x equal to log of x with the base a. As you recall, if a is greater than 1, we looked at the chart and we saw the shape of the graph from left to right increases. If the base a is between 0 and 1, like 1/10, the shape would be from left to right, would be this shape like that. So let's take a look at the characteristic. The graph contains the point 1, 0. Both of these gonna pass us through point 1, 0. which is the x-intercept. The x-intercept is exactly the same for both. The function is 1-to-1. To test for the function being 1-to-1 is you draw a horizontal line. If it intercepts the graph exactly at one point only, that would be 1-to-1. So that does pass that test here. When a is greater than 1, the graph would rise from left to right from the fourth quadrant to the first. Okay, from the left to right, from the fourth to the first quadrant, like that. When the base is between 0 and 1, like in this case, the graph will fall from left to right, from the first quadrant to the fourth. This is just a characteristic of behavior of the graph. The graph will approximate and approach the y is equal to 0, or you can say that the graph will approach the y-axis. This is the y-axis right here. But it never reaches that y-axis, never touch the y-axis. The y-axis is called asymptote. That's the name of this line. When the graph gets closer and closer to a line and never reaches that line, we would call asymptote. The domain and range of this function, take a look at that. The domain would be the value of x. It looks like the domain would be from 0 all the way to infinity for both of these. Not including 0. That's why we don't have a brackets here when we write an interval notation. So the parentheses 0, comma, infinity means all the numbers from 0 to infinity. That would be the domain. The range would be the value of y, which pretty much covers everything, because this graph is going to go down to negative infinity, and this graph, the other side, going to get increases, cover all the y-axis at the top. That's why the range would be all the number from negative infinity to positive infinity. These are the characteristics of the graph y is equal to log of x.